All right, in this quick video, I just want to show you putting in variables of different types in Swift based on what we just saw from the presentation. So again, I just have a blank project here. I'm going to start out with maybe my first variable. We'll call it planets. And it's going to take on an integer, which is going to be the number of planets in our solar system. And I could initialize it here, but let's not for now. I'll just declare it. And the way I've declared it is I started with var, I gave it the name, and then over here, colon, followed by one of the many different types that you can have in Swift. And again, this is kind of relating to what can actually be in the box, if you will. So it can only contain things of this type. So planets, the variable, is only going to ever hold on to integers. Then we can do another one. So let's say pi, and that will be a double. So that is basically any number that's going to have a decimal place to it is going to be considered a number. It's a floating point number. In Swift, we call it a double. The third one, let's call it name, and that's going to be a string. So again, we just declared variable, we gave it a name, and we said what type is it? What's it gonna store? And then finally, I can do is sunny, so sort of like asking a question, and that is going to be a bool, and that's a Boolean, which means true or false. And again, if you just watch the rules here, the rules are, first of all, in Swift, the types will all start with a capital letter, and therefore your variable name should really start with a lowercase letter. They don't have to, it's not required by the language, but it is convention and it's good form. And so that's what you're going to want to do when you do your programming. So now I've declared these variables here, but I haven't given them any values yet. So let's do that for planets. So to give it a value, I can just say planets equals or gets the value of, and in this case it's 8, right? Because Pluto's not a planet anymore, so we have 8 planets in our solar system. And of course, if I wanted to prove to myself that this works, I could say print planets, and then I'll do Command R for build and run. And sure enough, down here, I see the value 8, and that's correct. Now, keep in mind, I could have also initialized this right up here. So I can just literally take how I was copying this equal and 8 and put it up here, and then not do this. This would then be considered redundant. And now I've basically defined the type, and I've also given it a value. And this is very common. You will see this a lot where a variable is declared and it's given a value. Because this is a var, it means it could change over time. For us, in our example, it's unlikely we're going to discover any new planets in our solar system. But the point here is that this variable could take on a different value later because it's a var, and this would be sort of an initial value. Now, if we did let here, we are initializing planets to 8, and because it's a let, it's a constant. So if I came down here and I wanted to say, planets is really 9, and I go to build, notice it says it cannot assign a value to planets because it's a let. We've already assigned it here. Giving variables values, let's go ahead and do that for the others. So pi, let's say, is equal to 3.14, 3.1415927. So there's pi, and let's go ahead and print that. And there I have the 3.1415927, exactly what I put here. And this is a double. Now, what's interesting about this is that if I take out the decimal and I just say 3 here, and I go ahead and rebuild and run, it works. But you would think that, well, wait a minute, 3 is an integer and pi is a double, and I thought that we couldn't put one in with the other, which is correct. But 3 by Swift, what Swift has done is looked at this 3 and said, you know what, I'm going to not require you to convert it to a double or to type it as 3.0, and we'll just assume that for you, and it does an implicit conversion, if you will. And you can actually see that down here in the print because you see we get 3.0. We don't just get 3 like we did with planets with 8. So the reverse is not true, though. So for example, if I said planets equals 8.5, and I try to build that, I am going to get a compiler error here. And it basically, well, it's giving us two errors. Let's go back and make this a var so that we could reassign it. Let's go ahead and build again. And it's saying it cannot convert a double to an int. And basically the point is it's not going to take the 8.5 and drop that 0.5. It's going to just require us to either round it, cast it, or whatever. But at this point, it's not going to take a double and put it into an int for us. We would have to do something different. So let's take this out. And the third one is name. So that one's easy. We worked with strings a little bit before. So name is equal to, and I could put Kevin here. And again, you're just defining a string by always starting with an open double quote and a closed double quote at the end. And then whatever characters you put in between is what makes up the string. And then finally for is sunny is a Boolean, which is true or false. So if I say is sunny, and I'm going to say today it's not sunny, so it's equal to false, I have defined that variable. Let's just do name for a second, and then let's say is sunny. Go ahead and run these, and down here we see we have Kevin, that's correct, and we have false here, that's correct, because that's what I put in there for that Boolean. And again, any one of these could be moved up here like this, right? And we could initialize them. And then the final thing is type inference, which is also commonly used, where we could say that, well, when we say name is :string, and then it is given a value of Kevin, we actually don't need the :string anymore. So we take out that :string, we're still fine because Swift knows that this is a string, and therefore, if we're making this assignment, it's assuming name is going to be of type string. And that's true up here as well. We could take this :int out, and we could just say equals 8. It's going to assume that this is an integer, and then this will be an int. Now, if I said 8.5 here, we still would not get a compiler error. However, the type for planets would now be a double. And it would assume that because we put an 8.5 here. And that's what we mean by type inference. So those are types. Those are the 4 types. I've declared them here. I've set their values and I've printed them. So those are the basics for types in Swift.